I'm Mike Wofsy. I'm the inventor and also the CEO of SEA Desalination. Okay, the opportunity is very obvious. The population is increasing in the world, and our sources of water at best remain steady, and at worst actually decrease, because we have salt intrusions, pesticide runoff, and water investment is something that is finally on a lot of radar screens, not just in small scale, but also large scale. So the question is, the current industry of desalination is largely big installations. In some cases, multi-billion-dollar installations. For instance, desalination plants in Florida and Saudi Arabia, they require engineers, they require a lot of construction. Is there a market for personal desalination? And that's the question I hope to answer in this presentation. Okay. If you look at the electrical industry, you have solar panels, which are representative of small-scale electric generation. You have a simple panel, which requires very little maintenance. Anybody can open it up, take it out of the box, set it up, and start generating electricity. Now, the corollary for that, desalination, is something that you can take out of the box, set it up, and start producing potable water either from polluted sources or from pesticide runoff or from ocean water. This is the current industry. You can see that currently I'm going to analyze both the electric industry and the desalination industry, and the two are very closely connected as far as markets. If you look at the large-scale electric power industry, that's conventional electric power. Globally, currently, it's worth approximately $600 billion per year. Now, if you look at what I call the personal electric generation industry, which is photovoltaics, and it's true there is some crossover with photovoltaics, but typically this is what's called the personal electric industry, that's about $37 billion per year. Now, the desalination industry is currently worth $6 billion per year. So if you use the ratio of the personal scale electric industry to desalination, it would imply that there's an approximately $370 million a year industry in small scale desalination. Now these are the projected valuations. The electric power industry will grow by 100 billion, which seems like a lot, except that that's globally. But you'll see that the solar panels are increasing by about 35% per year. So in about 4 years, we're looking at about $91 billion per year. Now, if you look at desalination, GE, who's the largest desalination player right now, currently predicts that the desalination industry will be worth $12 billion in approximately 4 years. So if you then use that same extrapolation of the size of the solar industry growing, you'd see that the potential for small-scale desalination is worth approximately $1.6 billion per year. Now the question is, why is there a need for small-scale desalination? The reason is you can't always hire an engineer on site. You can't always bring in construction crews. You don't always have access to grid electricity or a large-scale electrical generator to produce your water, because conventional desalination is incredibly energy intensive. So, our solution is this thing. This is the solar evaporation array. It's made out of simple plastic, mass-produced. Water goes through the top. This is made out of FDA-approved acrylic, which won't cloud or crack in the sunlight. It captures rain. And very important for places like Texas and especially inland India, it doesn't emit brine. It captures the salt with crystals. So the crystals can be removed from the panels and then used as a co-product later. Okay, we're looking at early adopters of this technology to be military, for instance with a force multiplier. If you have a platoon of soldiers, that would be a good use for small-scale desalination. For a drip irrigation farm in India, or consumer-level products. Somebody wants to just clean their municipal water. Maybe they don't want chlorine in it. So those are our three main markets. Oh, then also, of course, disaster recovery. Hurricane zones, flood zones. It's a lot cheaper to send in 1 truckload of water and 1 truckload of sea panels than 6 truckloads of water. These are our partners. Currently, we have University of Alabama. We have operating under a $50,000 seed grant from the Alabama Launchpad, which we won last year. We have currently under a Phase 1 EPA Sustainability Grant, and we're in the running for the second phase of that EPA Sustainability Grant. Our team, they look a lot tanner on this screen for some reason. Theodore Prosiv is CEO of Versar Corporation. That's a project management corporation out of Virginia. He does work in Iraq and the Middle East, which is a good fit for our product. And he currently has about $500 million in funded backlog. Landon Miller is chief engineer at IBM and also a retired Navy commander. Shema Hyder, some of you may know from Dallas. She has a marketing consulting firm in Dallas. Dr. Stover is CTO of a desalination services company in California. There's me. My experience prior to this is I brought one invention to market, much smaller niche than this one. And prior to doing a PhD in physics, I was a science reporter for the Wall Street Journal and Australian provincial newspapers in Sydney. And this is our current headquarters. We're in agreement with the University of Alabama. We're at a high-precision manufacturing facility called the AIM Center. Our current valuation is $3.1 million. So for our first round, we're hoping for 18% equity sale. And in 4 years, based on the industry projections, we're looking at about $32 million. So we hope to take this, expand our products, and increase our intellectual property in this area, and come out with additional products to add to the ones we already have. Thank you.